Welcome to a quick overview of the central nervous system and how it functions. We're going to look at major divisions of the brain and also check out the spinal cord and some of the major functions there. First, we're going to look at these areas for the brain in a brief overview, and then go into the different sections with a little bit of detail and explanation on those. So enjoy the journey. So first of all, again, we're looking at the major divisions of the brain: the cerebrum, the cerebellum, the encephalon, and the brainstem. So for purposes of just showing this to you, we have the cerebrum here in the front, cerebellum here towards the base. The encephalon is actually in the middle of the cerebrum, and the spinal cord, along with the brainstem and spinal cord, right here, going out then to the rest of the body, to the peripheral nervous system. So first, let's look at the cerebrum. The cerebrum is divided into different lobes and hemispheres. Hemispheres are on the right and the left, and then we have the four different lobes: the frontal, the parietal, the temporal, and the occipital. And now let's get into each one. So the frontal lobe is primarily involved with various cognitive functions, from memory and recall and so forth, along with voluntary movement of the skeletal muscle. And then, of course, it is involved in language production. Now, language production specifically meaning along with voluntary movement, that is us producing and talking to you as I am now, and coming up with the words that I'm trying to say to fill in the presentation here. So cognitive functions, again, cerebrum dealing with higher brain functions. Let's move on to the parietal lobe. The parietal lobe is involved with the senses, and these senses, of course, include taste, touch, changes in temperature from hot to cold, and all gradations in between, and pressure. So this is involved with receiving sensory information and then interpreting that sensory information. The temporal lobe is involved in taking care of processing hearing, understanding and comprehension of language, and then, of course, emotion. So look at all three of those together. So we hear someone saying the words, we're working on processing what those words mean, and then in many cases those words can elicit an emotional response for that range of emotions that we have. And finally, the occipital portion of the cerebrum is involved in visual reception and then interpretation. So we're receiving sensory input from the eyes and the optic nerves, and then, of course, we have to make sense of it. So the cerebrum, again, involved in higher brain functions with interpretation and processing a lot of the information and stimuli that we receive, and then, of course, sending an appropriate response from this area to the next. And one of the things that we're going to look at next, going from the cerebrum to the cerebellum. And the cerebellum is working alongside the cerebrum in that voluntary movement, because now this area is involved in coordinating that movement. So hand-eye coordination, picking up a pencil, and moving your chair around, clicking on different slides, and navigating through our environment. Those are the functions of the cerebrum. Moving inside now to the encephalon. This is a relay station from the cerebrum and cerebellum to the brainstem, and then to the rest of the body. So the encephalon has different parts to it: the thalamus, the hypothalamus, the pineal gland, the pituitary gland. And this thalamus is, again, that big relay station from the brain to the rest of the body. Connected to that is the hypothalamus, which is then linking the brain to the endocrine system. And two of those glands within the endocrine system, the pineal and pituitary glands, these are again, the endocrine system is all about homeostasis within the body. So the hypothalamus is relaying to the rest of the body what hormones to release, getting directions there. The pineal gland primarily releases melatonin, which helps regulate our sleep cycle, and the pituitary gland is releasing various hormones for muscle contraction, lactation in females, as well as helping us retain water and regulating our blood pressure, either increasing or decreasing that. Of course, the pituitary also has a various number of hormones for growth and development. And now we're going to move on down from the encephalon to the brainstem. The brainstem is involved in a number of autonomic functions such as breathing, digestion, heart rate, again, coordinating with those blood vessels, and also various parts of alertness. Think of this in contrast to the cerebrum as very base functions, keeping us running and keeping the body doing what it needs to do. Not a lot of processing and thought involved there, but helping along with the diencephalon and the endocrine system, maintaining that homeostasis that is so important for our life. Now, moving down from the brainstem, we're going to go to the spinal cord. And the spinal cord, again, is responsible for reflexes, motor control, and relaying messages to the peripheral nervous system. So reflexes do not have to go to the higher parts of the brain for interpretation, because these are very base movements. The message can go to the spinal cord and then right back out. Each section of the spinal cord has various jobs, and we'll examine those here very briefly. So first, we're going to look at the cervical spine, and that is involved in breathing and heart rate and movement of the head and the shoulders, the neck, as well as the arms. Then we go into the thoracic or T-spine, which helps with that temperature regulation and movement of the trunk. Then we get into the lumbar spine, which is responsible for helping movement and reflexes within the hips, legs, and feet. Then we also have the sacral spine, S-spine, and that is controlling the bowels, the bladder, and other areas within the inguinal part of the body. Now, this is how, of course, this is all supposed to work, and this is good for maintaining homeostasis, but we also like to throw in some disorders here as to things that can affect it and how these diseases and disorders are being treated. So we'll look at two of these very quickly. Stroke for one and epilepsy for another. So stroke is starving the brain of blood and nutrients, and that in turn causes malfunctions throughout the rest of the body, paralysis in some cases, and new studies are revealing that using something such as an electroencephalogram or EEG can actually help patients who have suffered a stroke to regain some of that mobility that they had lost due to the stroke and damage that the nerves had received because of lack of oxygen and nutrients. So this electroencephalogram goes and sends these signals back to the brain and back to the nerves that were affected. And over time, those that had suffered mild to moderate strokes were seeing an improvement in the nerves that they had thought were now non-functional, or at least limited with that function. And so regaining that those messages and relays that had affected the brain and the rest of the peripheral nervous system, the orders, of course, now being restored. Epilepsy is, of course, particular interest to me, as I've had this condition for a number of years, and instead of the brain as a whole, the epilepsy is really looking at how the brain is relaying the messages from receiving stimuli, and as it really deals with the synapses, so more on a cellular basis, and how the synapses, those messages can be interrupted and cause more cascading kind of failure throughout, so that the messages that are sent and received get jumbled from the central nervous system to the rest of the body. Epilepsy is debilitating for a number of people, as the number of relays to the brain, the amount of messages that get sent and received, many times get overlooked on what we do. So this can be anywhere from absence to, we lack that memory for a specific amount of time, to petit mal and grand mal seizures, which are causing muscles to spasm. And new treatment that we're looking at instead of just medication is also how to identify the diagnosis for mutations that give people epilepsy from genetics, instead of just things like traumatic brain injury and so forth, and the information that they're gathering from genetics, as well as how to treat it in various ways, from surgeries to medications to manage it, have been very fascinating and interesting to see how these synapses can then be controlled, and then people can live that more normal life. So there is the overview of the central nervous system, the disorders that can affect it, as well as some of the treatments that are occurring for that, for strokes, how to treat brain injuries and so forth, and getting those drugs to work in the brain, as the brain is very well protected. So list of the places where you can find some of the treatments that are going on. And again, with every brain and every body system that we look at, we also need to look at how we can treat disorders and understand how the brain works and how the body works. And then the more we understand, the more we can look at treating it and helping people regain a sense of control and a sense of power within their lives.